All right, Brandon Clayton here, the Algebra Guy. Today, our discussion will be over solving quadratics by factoring. All right, so by the end of this video, you will be able to do, first of all, this TEAK, A.A, solve quadratic equations having real solutions by factoring. So in particular, we're going to talk about the zero product property, which is very important when solving. We're going to talk about solving quadratics by factoring and using applications, so actual word problems that you'll see embedded with this skill. So let's get into it. Now, up to this point, we've talked about linear equations before, and you've recognized this form, at least I hope you do. Do you remember what the name of this form is? Standard form. Good. So ax plus by equals c. This is standard form. Now, our standard form for a quadratic looks very similar. It's going to be ax squared plus bx plus c equals 0. So this is, you're going to see us get into that form quite a bit when setting up to solve for a quadratic. All right, so the zero product is simple. It simply says that when you have two entities multiplied to each other to get 0, one of them has to equal 0. For instance, if I have x times y that equals 0, well, the zero product says that either x is 0 or y is 0, because anything times 0 has to, one of those have to be 0. Or both could be 0. So applying that to this, these factors, what would that mean? Well, so if I thought about these factors in a term of like, this is my x, like let's say this is, let's not use x and y, let's use c and d. So if this was c times d to equal 0, well, what do you know about c and d? Well, not knowing what the numbers are, it doesn't matter, because I know one of them is equal to 0 or both are equal to 0. So in that same sense, I know that this x plus 1 times x minus 4 is equal to 0. That means this one either has to equal 0, so x plus 1 has to equal 0, or x minus 4 has to equal 0. So I know one or both of these have to be true. So guess what? In order to solve this, I check to see what makes x, what can x be to give me a 0 in both of these cases. So I'll go ahead and solve that by subtracting 1 on both sides. X equals -1, and over here, you already see it, but I'm gonna do the work anyway. X is gonna equal 4. So I know that there's two possible solutions here. X can equal -1 or x can equal 4. Now when dealing with quadratics, don't get surprised to see two solutions, right? Because with a line, we're used to seeing only one, but having a different shape, a parabola shape like this, causes there to be two solutions. And we'll talk about this later, but those solutions are going to be at these points here, called x-intercepts, zeros, solutions. We'll discuss that later, but that's really what we're after now. Up to this point, we factored just so we can get to this point where we can finally start to solve it. So, as usual, let's get into some practice. All right, so for these two, solve this one, please. N has to equal what? Now, if you want to pause it and solve it now, that'd be great, but I'll go ahead and start it. But challenge yourself each question, please, before I answer that question, to pause your screen, even if I don't tell you, and see if you can answer. You'll learn a lot faster that way. All right, so I'm going to set both equal to 0. This factor and this factor equal to 0. So I'm going to start it with 5n minus 2 is equal to 0. And I'm also going to do 6n minus 1 equal to 0. Why? Because I'm going to reiterate the importance of, if I have two factors, let's call this c times d equals 0, that means either c is 0 or d is 0. So I'm setting this whole thing equal to 0, or in this whole factor equal to 0. And we're going to solve to find out what are my possible solutions. So let's go ahead and solve it using some basic good algebra here. Adding 2 to both sides. That's a not pretty 2, but 5n equals 2. Divide both sides by 5. And we end up with n equals 2/5. That should be an n, not an h looking thing. All right, so over here we get adding 1 on both sides. 6n equals 1. Divide by 6 on both sides. And n equals 1/6. All right, so these are my solutions. And get comfortable with fractions, by the way. Please don't try to change those to decimals. You're going to have a much friendlier time in algebra by keeping your fractions for many reasons. As you've seen already, counting slope and just adding and subtracting. Plus fractions are a more perfect number. They're not, you're not chopping off a decimal somewhere at the end or saying it's approximately this or that. So that's a little side note. So my solutions here are going to be 2/5 and 1/6. Those are the answers that I could get in order to get a 0. If I were to put 2/5 in here, this would make this 0, which turns this whole thing to 0, because 0 times no matter what this is goes to 0. Because someone might say, well, if you put 2/5 here and 2/5 here, this isn't going to be 0, but guess what? It doesn't matter, because the zero product says anything times 0, this one's 0, will make that 0. And vice versa for this 1/6. It'll make this 0, so everything's 0. All right, so I won't continue to say that, but I want to make sure we make that point very clear as we move forward. Now, what about this one? This one doesn't have 2 parentheses, but there are 2 factors. Do you see them? One is going to be this 3p, and the other is this whole thing right here, right? 10p plus 7. This whole piece. So please see both of those factors. And so again, this zero product rule is true. Whereas some, I'm still going to call it C and D, just to have different variables, equals 0. That means one of these have to equal 0. So I can set 3p to equal 0, and I can set 10p plus 7 to equal 0 to find my solutions. Well, to get p by itself, I'm going to divide by 3, and p equals 0, because 0 divided by anything is 0. So I put 0 there to get one solution, and subtract 7 over here. 10p equals -7. Divide both sides by 10, and I'm left with -7 over 10. So -7/10. Those are the 2 solutions I could get that would give me a 0 here. So that's how you solve a quadratic. What about this one? Now keep in mind, y minus 8 squared is simply saying we want that entity twice, right? So this and this. So we still got 2 factors. They just put it all together because it's a perfect square. But what does this have to be? Well, we know that if this was C and D, and in this case it's C and C, but if it's going to equal 0, one has to be 0 or both have to be 0. And since they're the same term or the same binomial, it's going to be the same number. So you could probably visually see that this y minus 8, if I set that piece equal to 0, 0 squared, 0 times 0 is going to be 0, so it doesn't matter. But I add 8 on both sides, it's going to give me y equals 8. So 8 minus 8 is going to be 0. That's going to be my solution to there. There's only one solution. No, not 2 solutions, only one. At y equals 8, there's a solution in this case instead of 2. All right, so how do I solve by factoring? Up to this point, we factored these. So it was everything minus, like we didn't have, let's see if I can, I want to scratch it out. But we didn't have this 0 here, equals 0. We just had this piece and we've learned how to factor. Now we want to factor and set it equal to 0, bringing everything we've talked about together. So let's go ahead and factor this piece. And by factor, we're going to find what these 2 pieces are. And now I'm going to set it each time equal to 0. So what goes in here? So we've talked about how to find those 2 numbers, and we've used the box method and the big X to do so. It's not as necessary for this problem because our a is equal to 1. However, I'll still continue to be consistent and try to keep this in front of us. So this is x squared, this is minus 8. We need these 2 numbers. So to find that, I do a times c, which is -8. And my b is 2. What 2 numbers multiply to give me -8 and add to give me 2? Well, the factors of 8 is 4 and 2, 8 and 1. 4 and 2 will work, but I need a 2 from those 2 when I add them, so I need to subtract 2. 4 minus 2 would give me that, and 4 times -2 would give me that. So these are going to be my factors. So it becomes clear now that these are my factors I'm going to use. Now, if you're confused by this part, please go back to factoring lesson that I'll spend more time on how to go through that step by step. X minus 2, so those are my factors. Now we want to go a step further this time because now we're actually trying to solve it. We're not okay with just factoring them and looking at it. We want to say, what does X have to be to get 0? And you can just see that, right? I'm going to go ahead and write it out, but I know you know what the answer is. So X plus 4 needs to be set equal to 0, and X minus 2 needs to be set equal to 0. Subtracting 4 on both sides. X is -4. If I add 2, then x is 2. Now I want to keep doing this, but for the first couple of problems, I want to make sure you see exactly where I'm getting those numbers, because some students may want to simply say my answer is 4, but that's not the answer. In order to get 0, x has to be -4, and you see why, because -4 plus 4 gives me a 0, and 0 times anything gives me a 0. I need an x equals 2 to get 0, because 2 minus 2 is 0. So that's why I want to make sure I take step by step to see that. So my solutions are going to be x equals -4 and x equals 2. And yes, I did say solutions, because again, it's not uncommon to have 2 solutions for a quadratic, as you see. All right, what about this one here? So I need to get this into standard form, and by standard form, remember I'm talking about ax squared plus bx plus c equals 0. Currently, I have it not in standard form. I have the ax squared here, and I say x, but it doesn't matter what variable, but the idea is get everything on this one side and set it equal to 0. So I'm gonna rewrite this, subtracting 13y, and I'm gonna subtract 45 to get it over here, and now it equals 0. So what did I do? I just subtracted 13y on both sides, and I subtracted 45 on both sides. So this went away to 0, and it brought it over here, changed the signs. Now what do? I first check to see if I can take out a greatest common factor, and I can't, because 2 is my biggest number, and I don't see these being even, so that's not going to work. So now I have to figure out another way to factor. As we talked about in the previous lesson, factoring when a is not equal to 1. So I'm going to take out the box again, and I already know I'm going to use the box next, so I'm going to draw that. I know my number up here is going to be 2y squared, and my -45 is going to go down here. That looks like a 4. It needs to be a y. Okay. We need 2 numbers to multiply to give me -45, and I'm sorry, that's not right. Not -45. My a times c. 2 times -45, which is -90, and add up to give me a -13. Now that doesn't seem fun to do. You could use your calculator to do this, and I may do that. Let me play around with it a little bit and let's see if we can get it without too much hassle. 1 times 90, 2 times 45, that's not 13. 3 times 30, 4 times, that's not gonna work, is it? So, but 5 will go in here. What is that? 5, 18 times. Is that going to work? Yeah. So here it may work right there. So let's check that one. 5 and 18. Why 5 and 18? Because 18 minus 5 gives me 13. So if I take away, make this negative, I can get a 13 by adding these two together. And if I multiply these two, I get a -90. So these look like it will work. Yay, I didn't have to take my calculator out. And if you're wondering how to use that, again, a previous lesson on factoring with those, I'll show you how to do that. So what are these two numbers? So let's take the greatest factor out of 18 and 45. And I believe it's going to be, what is the biggest factor? I want to say, well, I have to actually figure this out because I don't know. So I'm going to take all my factors out of 18. 2 times 9, which is 3 and 3. And 45 is 9 times 5. So that's going to be 9 is 3 times 3 and 5. So here I can figure it out. So what factors do these two have in common? They have a pair of 3's and a pair of 3's. So I know it's 3 and a 3, and it looks like that's it. So it looks like the 9 is the biggest that I can take out. My number here is negative, so I know that's going to be a negative. So my arrow finishes in this box, so that's going to be a negative. If I look up here, I have a y I can take out. And 2 and 5 only have a 1, so it just stays that way. Going across to the left, I have a y I can take out. And 2 and 18 have a 2 in common. Going across here to the left again on the bottom, I have a 5 I can take out of both 5 and 45. So those are my factors. I have 2y plus 5 coming from here, and y minus 9. All right, so we're almost done. Before this was just enough, but now we want to solve it. What does this have to be to get 0, and what does y have to be here to get 0? So let's figure that out. I'm going to change colors to show that I'm doing something different here. I'm going to go 2y plus 5 equals 0 and subtract 5 on both sides. 2y equals negative 5 and divide by 2 gives me y equals negative 5 over 2. So one of my solutions is there and the other is really easy. Nice little break here. This has to equal 0, so that's plus 9. And so this is going to be y equals 9. So y can equal 9 or y can equal negative 5 over 2. Those two would be my solutions. All right, so let's look at another one, not in standard form. I would love for you to pause it here and work this one before I do, so that you can get a really good feel for kind of the things that you're getting and things that you may not be getting. All right, first thing I'm going to do is rewrite this so that it's in standard form of a quadratic equation. Equals 0. And all I did is subtract 7x on both sides. That's why this 7 is negative. So that equals 0. I can't take out a greatest common factor here, so I'm going to have to go back to my box method and my x to think through what these numbers could be. So I know I have a 5x squared here and a negative 7x. My a times c is negative 35x. I'm sorry, negative 35. Because I shouldn't have put x there, shouldn't I? I'm glad that happened because I just realized these numbers should have combined. So let me rewrite this. Oh my, good catch. So negative 13 minus 7x should have been just one number. 5. We should have just been combining like terms there. So I got so caught up in the same rut that I almost missed it. Now this makes it a little bit different, because I see that I have some GCF, some greatest common factors. 5 and 20 have a greatest common factor of 5. And they both have at least one x. So that makes this a lot nicer. And so this is going to be factored this way, because 5x times x is 5x squared, and 5x times negative 4 is negative 20x equals 0. Oh yeah, this is much nicer than having to use the box or anything like that, because I was able to factor this out so that I can see both of these. So I have two products. I need to make sure 5x is equal to 0 and x minus 4 is equal to 0. Well, dividing by 5 on both sides gives me x equals 0, and adding 4 to both sides is going to show that x equals 4. So there's my two solutions right there, 0 and 4. Yay, I'm so glad I caught that. And I'm going to leave that edit in. I like to leave my mistakes in there. I don't know if that's a mistake, but it could have been a pretty big mistake if I kept going. But notice we can get into a habit of doing a problem a certain way, and they'll throw in something like this and it'll throw us off. But all you had to do was combine those and factor everything out, and it made it so much easier. All right, here's another one that's a little bit different. How do we handle this one? So we have these two factors equals 3x. Your first instinct is to do what? You want to set this equal to 0 and this equal to 0. However, it's not set equal to 0 yet. So this eventually needs to come to the left so it can be equal to 0, but right now it's not. So what I'm going to do is multiply these two factors and then bring it over here to see how we can get rid of, to see what new factors we can come up with. So let's go ahead and multiply 3x minus 8 and x negative 1 to see what this is going to equal. So this gives me negative 3x and 8. So that means this is going to equal 3x squared from here. And I combine these terms right here to get negative 11x and plus 8 equals 3x. So all I did was multiply these two to get this. Now I'm going to subtract 3x. Subtract 3x and see what I come up with. That's 3x squared. These two give me a negative 14x plus 8. Now it equals 0. There we go. So now we need to look at this and see if we can find the factors that we can break this into. I know there's going to be x's there, but I don't know at all what these numbers are going to be. So we need to make a new box. me get rid of our old box. No, not a happy face. So we're going to get rid of this box, and we're going to make a new box to try to factor out to see what these numbers could be. So we're going to draw a box. We're going to put this term in the top right, and this one always goes in the bottom right. And here's our x. A times c, that means 3 times 8 is 24. And we want two numbers to add together to get negative 14. I'm going to just, these numbers are small enough that I feel like I can just write down the factors to figure out what that number is. Those numbers are. So I'm going to do that. 2 times 12. And already I see 12 and 2 gives me a 14. I'm going to write down a couple more just in case I'm missing anything and I don't see anything else. So I see 2 and 12. Now the signs need to change obviously to get this 14. So these both have to be negative to add up to negative 14, and they both have to be negative to multiply to get 24. So we are good. This is going to be negative 2x and negative 12x. So now I can find my factors. If I look up, I know this is going to be a minus because this last box that the arrow finished on was a minus, and they have a greatest common factor of 2 between 2 and 8. If I look up here, I see 3 is going to be my greatest factor, and they both also have an x. I look across, 3 and 2 have only 1, but they do have an x. And 12 and 8 have a 4, and it's going to be a minus because this box right here, the arrow finishes on a negative box, so I know it's going to be a negative 4. So the greatest common factor is 4 between those. Those are my factors. I have 3x minus 2, 3x minus 2, and x minus 4. I need to set both of these equal to 0. So 3x minus 2 equal to 0. So I'm going to add 2 to both sides. 3x equals 2 and divide by 3. So x is 2/3. There's one of my solutions, and the next one's pretty easy. This is kind of fun when it's that easy. So x is now going to equal 4. So those are my two solutions. X equals 2/3 and x equals 4. But let's back up and make sure we understand what just happened. So they didn't give it to us in standard form. We had a 3x here instead of a 0. So we needed to bring the 3x over to this side. But first we need to multiply these two to find out what polynomial it gave us. So then we subtracted 3x and we got busy doing what we normally do, finding those factors. All right, again, I'm going to shoot a pause and see if you can work this one. This is not in quadratic or standard form, so I'm going to subtract 16x and subtract 84. That's going to make it 0 on this side. Well, I'm going to do the same thing on this other side, which is going to give me 4x squared minus 16x minus 84 equals 0. I'm going to go ahead and write it out, what I did, in case anybody's confused. It's equal. So I just subtracted all this and get it on this other side. All right, so now we start working. We need to factor these things, but first, is there a GCF I can take out, greatest common factor? And I believe there is. 4 can be taken out. So that leaves me x squared minus 4, and this is going to be 21. 4x, and this is 21. Yep, 21 equals 0. And look at this, I have x squared minus 4x minus 21. So that looks nice because there's a equals 1, which typically is an easier problem when a is equal to 1. So let's look at it and find out. I could probably do it in my head. You could probably do it in your head once it's that small. We know it's just going to be x's here. 7 and 3. Yeah, that's the only factors of 21. So 7 and 3. And I need to add them to get to a negative 4. So this 7 has to be negative and this has to be positive. So I really don't need to do this method when it's that small and you get used to doing that. I'll go ahead and fill these boxes in the way I normally would have. Otherwise, for those who got uncomfortable with that. So 1 times negative 21 is negative 21. Add to get negative 4. We decided that 7 and 3 works, but it has to be a negative 7. So that's what gave us these numbers. Negative 7 and 3x. And we fill those in there. So this has to be x minus 7 needs to equal 0. and x plus 3 needs to get a 0. Don't worry about the 4, again, because there's no variable on the 4. There's no x there, so you don't have to say 4 equals 0, because that doesn't change anything. Now, if there was an x right there, yes, we'll look at that. But we're only concerned about these two factors here. This one can be x equals 7, and this one's going to be x equals -3, because 7 minus 7 gives us 0, and -3 plus 3 gives us 0. So those are the two possible solutions here if I were to add, solve for 0 on both of those. So just reviewing, I put it in standard form, then I factored out my greatest factor. And by the way, you could work it this way without factoring, but man, what a beast that would be. All right, to look at 4 and 84, multiplying those and trying to find a number in between, unbelievable. So just factor out as much as you can. When we factor further, we were left with x minus 7 and x plus 3, and that was easy to solve. X equals 7 and x equals -3. Those were the solutions I needed to get 0 for each factor. All right, so let's look at some ways this may be applied. You may see a problem like this. This is a very typical problem. The product of two consecutive integers is 132. What integers are we talking about? So what two numbers, consecutive numbers, give you 132? It sounds like a crazy problem. You're like 3 plus 4, those are consecutive, but they don't give me 132 when they multiply together. So how do you set that up? Well, normally we use n when we're talking about integers. So we're going to say we'll let n represent some number, and then the next number we'll let represent by n plus one more. Why? Because they're consecutive, right? They're in order. It's 3 plus 4 is one more. 50 plus 51 is one more. 52 plus 53 is one more than 52. So we know it's some number and then times some other number plus 1. So we know that when you multiply these two numbers, they're going to give us 132. So n times n is n squared. N times 1 is n. And that gives us 132. Well, what is this starting to look like? A quadratic equation. Matter of fact, we're almost there. If we subtract 132 on both sides, we end up with just what we're looking for. N squared plus n minus 132 equals 0. So we end up with a quadratic now in this form. My goodness, what numbers are those where you can get this setup? So anyhow, that's our next challenge, right? So we need to find these two factors. What are these two pieces going to be? Now we got to set up properly. What are these two numbers going to be? So I could do my 132 and come up with all the factors there could be, but I'd rather not do that. So what I'm going to do instead is use my calculator. So let me pull out my calculator and see if we can do it that way. I think that'd be more beneficial. So what we're looking at on my screen is, you still see this writing here. For the purpose, I just want to show you what we had before I go to my graph. But we're looking for two numbers that multiply. So if I make my x right here, we're looking for two numbers that multiply to give me 132 that add up to give me a 1, because that's my b. So 1 times 1, -1, oh, it's just -132, and give me a 1 in the middle. So we're looking for, they have a difference of 1 apart. So I'm going to pull up my calculator and see if we can help find it. So I'm going to erase this so we can see this better. But let's go to our calculator and see if we can find this. And the way we do this is we basically tell the calculator that we want 132, and we want to divide it by x. If I can get it pulled up. All right, here we go. So we got 132, and we're going to divide that by x. And what we're in essence, what we're saying to the calculator is we want to do 132 divided by 1, 132 divided by 2, 132 divided by 3, and we want to keep on going, and we want to see all those combinations instead of writing them out ourselves. So I press enter, and I don't see anything, and that's okay. I'll actually want to pull up the table and see that long list that we were about to create. And look, we actually have a whole list of all the factors of 132. 1 times 32, 2 times 66, 3 times 44. And what we're looking for is which of these have a difference of 1. So 6 and 22, that's not a difference of 1. So we're going to keep going down, and look what I found. 11 and 12 have a difference of 1. So guess what we're going to be using? Yep, you guessed it, 11 and 12. So I'm going to go back to our problem now, and we're going to use those two. So let's see if I can pull up what we just talked about, and here we are. So how is that going to help us? So we know that 11 and 12 will work. I want a positive 1, so I'm going to subtract the 11. So I have minus 11 and plus 12. So if I keep going, to solve this to equal 0, that means n here needs to be 11. And if I went ahead and solved this one, n plus 12 equals 0. Minus 12, n equals negative 12. So n equals 11 or n equals negative 12. Which one makes more sense? To have n equal 11 and the next number be 12? Those are my two consecutive integers, 11 and 12. Or would it be negative 12 and negative 11? So negative 12, those are two consecutive integers. Now, the cool thing about both of these is they'll both be right. They're both consecutive and they're both integers, and multiplying both of these give you 132. So we can say that 11 and 12, those integers can give me 132. Negative 11, negative 12 are both also consecutive. Let's see if I added, if I made that negative 12 and added 1, yes, they give me negative 11. So both of those could work. So you see why quadratics will sometimes render two answers. But 11 and 12 would be an answer there that you want to go with. All right, here's a very typical problem for dealing with quadratics. A rectangular garden has an area of 15 square feet. So this area, ooh, not a good color. Area is 15 square feet. The length of the garden is 2 feet more than W. They went ahead and set it up for you. They normally don't do that. Find the length of the width of the garden. So we need to know area of a rectangle first. Area of a rectangle is equal to length times width. And this area is going to be, well, we were given area, so we know that the area is 15. And I'm going to rewrite it so it looks more like a quadratic. So length times width is W times, let's put the parentheses, times W plus 2 is equal to my area, 15. So look at what we're saying. Length times the width is equal to area. So they said W, and it doesn't matter length and width because they're multiplied and it's going to get the same answer. So I don't get confused saying, oh, that's the width, that's the length. But we do know when we multiply these two, we should get 15. So let's go ahead and distribute this and get W squared to W equals 15. All right, and to get this in quadratic form, standard form, we're going to subtract 15 on both sides to give us this. And now we have our quadratic ready to be solved. So we need to know what numbers are going to go in there. Two numbers to multiply to give me negative 15, but add up to give me a 2. Well, 3 and 5 are the first that come to my mind. It needs to be negative, so one has to be negative. So the 3 can be negative because negative 3 plus 5 gives me a positive 2. So this is going to be negative 3 and a positive 5. Now it becomes easy to see that W can have two solutions. It can be 3, don't say negative 3 because 3 minus 3 gives us 0. And what else? Negative 5. Good. So I can have those two possibilities. Which one is it? You can't have both as a width. Well, one just doesn't make sense, does it? You can't have a negative 5 width. So, but you can have a 3 feet in width. So 3 feet is going to be our answer here. Let's make sure we answer the question. Find the length and width. So we know that the length, that this length here is going to be 3 plus 2, which is 5. So this length is going to be 5 and the width is 3. I'm going to jump to some star questions that come up regarding this subject so you can see what it looks like on the star. So here's a question that was a couple of years ago in this same skill, the same teak. The total number of seats in the auditorium is modeled by this function, f of x equals 2x squared minus 6x, where x represents the number of rows of seats. This x represents the number of rows of seats. How many rows are there in the auditorium if it has a total of 416 seats? So f of x is going to represent our number of seats. So you need to remember how to set that up. What is representing what? And this is our number of rows. All right, so if that's the case, we can say, we can know how to set this up. We can say f of x, which is the same as y, is equal to, actually they already wrote that, I'm not gonna write that again. We can say our number of seats is equal to 416. And we're using this equation 2x squared minus 6x. Notice that we're almost in standard form, so I'm gonna go ahead and put it in standard form by subtracting 416. I noticed that I have a factor that can come out, which is a 2. So I take out the 2. And 416, I believe, will give me 208. And that equals 0. So, man, look at this huge, who wants to do that by hand? Now, the cool thing with the test is, look, it's multiple choice. So you can literally plug in 4 numbers to see which one after you solve is going to give you a 0. But if you don't know at all, you can actually factor this the way we've been doing it. You can take negative 208 and look at all the factors until you see one that has a difference of 3. Now there's a number of other ways you can solve this that I'm going to go over in another lesson that talks only about how to solve these using the calculator. So I don't want to get into too many of the calculator features now. So I'm going to use our old skill that we just talked about. I don't want to introduce anything new just yet. On the graph, this time I'm going to say 208 divided by x. And I'm going to press enter, and I'm going to look for where there's a difference of 3 between x and y. So I'm just kind of scrolling down. It's so fun because it's so quick, as opposed to trying to figure out all these numbers. So now I can see 13 and 16 have a difference of 3. So those are possible solutions here. 13 and 16. So when I already can see 2 answer choices in here, right? That says 13 and 16, but which is it? So if I put in 13 for x, I get a 16. If I put in 16, I get a 13. So how many rows are there in the auditorium if there's a total of 416 seats? We need 416. There's 2 possible answers, 13 or 16. All right, in order to figure out which one this is going to be, I need to look at this with the same model I did before. Negative 208 and 2 numbers to give me a negative 3. So what can that be? I need 13 and 16 need to come together to give me a negative 3. How can I get that? Well, I could try 16 and 13 and make negative 16 that negative, and that will work because negative 16 plus 13 will work. It won't work the other way if I did. Well, I don't have any other factors that I see. So negative 16 and 13 is going to have to work. So I can break this into x minus 16 and x plus 13. Well, doing that will show that I can have x equals 16 or I can have x equal negative 13. Well, x represents what? It represents the number of rows. Can you have a number negative 13 number of rows? No. So the only other choice now, see, this would be a popular second choice when you see those 2 choices, but that's not right. You can't have a negative. So you have to go with 16 on this one because this is the only solution that will make sense because you can't have a negative 13 value. All right, okay, let me close that. All right, and here's one more pretty typical problem that came up on the STAR a few years ago back in 2015. So this is very similar to what we've already been working, so you won't be surprised to see how we work through this. Matter of fact, why don't you try to work this and see what you come up with. I'm going to put the 3x squared there. This is not in standard form yet, so I need to write it so that it is. By subtracting 18 on both sides gives me equals to 0. Now instead of putting 18, I need to make sure it's negative 18 there. I can factor out, actually I should have did that first. I can factor out a 3. So this makes this 5x and minus 6, and that makes it a little bit easier. So now I know that I have two numbers to give me negative 6 but add up to 5. What two numbers? So one of them has to be negative, one has to be positive, so I'm going to go with 6 and 1, and we're going to do it that way. 6 minus 1 is 5, and 6 times negative 1 is negative 6. So I know this is going to be x minus 6 and x x plus 6 and x minus 1. So that's what we're looking at. So the question is, what are the solutions? Well, to get the solution, this has to equal 0, so that's going to be a negative 6 to get 0, and this is going to have to be 1 because 1 minus 1 is 0. So those are my two solutions, and you better believe they put some good answers there that could confuse a lot of people, because 2 and 3 kind of looks like it will work here too, but it doesn't. So negative 6 and 1 are my two answers. Negative 6 and 1 is what I would be looking for there. All right, guys, thanks for tuning in. Did we cover everything? Yes, we talked about how to do this by factoring. We'll talk later about how to use a calculator, because there's a lot of fun features you can use in your calculator, but I want to stick to factoring as much as I could in this lesson. We covered the zero product and we talked about factoring, and we use real life problems that you'll likely see. Thanks for tuning in again, and I will see you next lesson.